Hi, my name is Bata Lipska and I'm a DevRel at Trilitech. And in today's episode, we have Javi from Goldsky. And if you haven't seen the very first episode with Andrew, I think you should just watch it. The link should be in the description down below or linked somewhere here. But so the very first one was about a very high-level overview, and we've learned about Goldsky features and products. And today is the hands-on experience, and so we have a solutions engineer, Javi. So I think it's good to just get your hand dirty and learn a new super fun skill using Goldsky. Javi, the stage is yours.
Yeah, thank you for the nice introduction. Not much to add to that. Yeah, my name is Javier. I've been with the company with Goldsky for over 2 years. And yeah, I know you already have a kind of a nice overview from Andrew in the previous recording about what Goldsky is. But for those of you who haven't watched it yet, we are an enterprise grade indexing solution. And today's workshop is all about how to use our main two products, which is subgraphs and mirror, to index Etherlink data. And so, yeah, let's actually dive into that. I'm gonna share my screen. Let's see if it works like before. Cool. All right. Okay, cool. So indexing and streaming Etherlink data with Goldsky. Yep, my name here again. Yeah, solutions engineer at Goldsky, and we can jump into the agenda directly. So what I will be covering is I'll start with the basics because maybe not everyone is so familiar with indexing. And then I'm going to take you from the very beginnings of, indexing all the way down to basically ETL solutions like Mirror, which means that, we'll be creating pipelines where Etherlink data can end up in your own database, essentially. All right, cool. So let's start with why indexing is important, right? And so if you think about the blockchains, they are particularly interesting in the sense that we can write a bunch of data into them, but they are quite inefficient when it comes to reading the actual data from them. And so, you're all pretty familiar with the structures within a blockchain, but, it's basically an infinite sequence of blocks. And within these blocks, you can get more granular and you can find more information like transactions, logs, traces, etc. And if you look at the data itself, it's all encoded and it's just like very complicated to work with. So originally, how the chain was read from the very beginning, back in the day, it was all about relying public methods within contracts. And so, we did here, although you may not be able to see it, but this is just a little example of code where we're trying to display 20 NFTs, right? Just a page displaying 20 NFTs. And this is just like taking 41 network requests, and it just took around 1 minute, right? So the original methods of requesting data and interacting with the chain via essentially making direct ERPC calls to the node, they're actually quite inefficient. And so as a result of it, and as a kind of a natural evolution to it, indexing became the most natural way of capturing the data. So when you hear indexing, you can think about indexing as just basically being a way of creating a parallel database where it will store the same information, but it will be stored in a way that is a structure for you to be able to query and interact with it in a much more cohesive and in a much more efficient way. So these indexers, you can think about them to be something like blockchain scrapers, right? Like Google scrapes the data on the web. Indexers will scrape the data from blockchains, and that's pretty much all it is. When you look at how we went from direct ERPC calls directly from the nodes, then most natural next steps has been subgraphs. And so subgraphs are basically today the de facto indexing technology. And the way they work essentially is that you have the indexers scraping the data. They will take the data and they will put the data into its own database layer, which is Postgres. And then from it will directly give you a GraphQL endpoint for you to be able to query that information very, very easily. So subgraphs have been around for a few years already, and they are open source. So in our case with Goldsky, we've taken that technology, which is originally being developed by the graph, which means that we are fully compatible with the graph. But on top of that, we've added quite a few nice features, which we're going to be talking about in a second. And that this will be increased query performance, better reliability, support, SLAs, etc. And then on the technical side, some features like instant subgraphs, webhooks, tags, load balancing, etc. So that's pretty much a little bit of it, right? We go through direct ERPC calls. They're not that efficient. Takes a bunch of time to load on the website, to being querying a different system, which is basically an indexer where the data is stored in a much more convenient way. And if we look at subgraphs, this API endpoint is going to be a GraphQL endpoint. Now, what we're going to be doing now here is just that showing you a little example of one of these subgraphs. But if you are any familiar with subgraph development, you will probably know that in order to create a subgraph, you need to rely on building a scaffolding of folders with a bunch of stuff on it. In our case, we kind of acknowledge that not everyone wants to learn how to develop subgraphs, or not all the science that comes with it. And for that, we created this thing called instant subgraphs. So instant subgraphs are basically a way for anyone to be able to deploy subgraphs just using a config file and an ABI. And so if you're familiar with subgraph development, you can think of this as being, you provide the data that is in the YAML file and the ABI, and then we will be creating the mappings and the entities for you. Cool. So that's the theory. Let me just quickly show you an example of it. So if we go to app.goldsky.com, you will first have the dashboard presented. For those of you who don't have an account yet, you can go to goldsky.com and go to sign up, and you can very easily create an account without having to put on any credit card or anything like that. You will be having access to a free trial. So very easily you can deploy up to 3 subgraphs for free, as well as 1 pipeline. And the pipelines we're going to be covering later. When you get into your dashboard, you're going to be presented with the subgraphs page. And so here you have a nice overview of the subgraphs that you have deployed. So in this case here, we're going to be going through deploying the instant subgraphs. And that can be easily be done here on the deploy subgraph. Let me just move this up here. When we click the deploy subgraph, we have this model, and it's going to ask us for the basics of the subgraph that we want to deploy. And so there we go. So what I'm going to be doing now, for example, I will be deploying an instant subgraph for any token within the Etherlink network. And so let me just go through it actually very quickly. So I'll go to Etherlink Explorer. Let's actually take a look within the Explorer. We can look for tokens, for example. And here we are, tokens. We have a list of the most traded tokens. So for example, we can take USDC. We can, in this case, we can create a subgraph that will track events to USDC contract. I can go into the actual contract itself or the address itself. So now let's look at what details we need, right, to deploy the subgraph. We need a name. So for name, I'm just going to call this USDC Etherlink. Subgraph version is going to be the first one. That's good. The contract address, we have the contract address from the Explorer, which is also good. Now we need to select the network. There's a bunch of network in our indexer, so you can just look for it by typing the name. So in this case, Etherlink, right there. And then we can define a start block. This is also optional, but in cases where you, for example, you want to index your contract and you know that the block which was deployed, it's just going to be much faster if you specify it here. So in our case, we can track from the very beginning when this contract was deployed, or maybe we can just make it easier. Let's look at the transactions here. And there's a bunch of transactions. I can take, for example, this transactions block. I can use that. Maybe it's just as time. just say 00, just to give you some more time on it in the past. And then the contract ABI, very important. The ABI, we will need the ABI basically for the subgraph to be able to translate the events into something that we can understand. And so you can find those usually within the Explorer. That's going to be in the contracts. Let me just see here, ABI, cool, just the ABI. In reality, this is an ERC20 contract. So, ERC20 ABI is just going to work the same. So what you see here, I just filled in the basic details of it. And with that, I can now deploy the subgraph. Now, in the backend side of things, and Goldsky is going to be creating the code for you to be able to query that subgraph. So if we just see the code here, we can now see that the subgraph has been deployed, and I can click on this page, and this is basically going to take me into the subgraph details page, which I'm going to walk you through in a second. But as I was saying before, the kind of the magic of the beauty of this feature is that you don't really have to worry about building the whole scaffolding folders to deploy the subgraph. You just provide those config details, and we will be building the subgraph on your behalf. Okay, cool. So now I'm on the subgraph detail page. And just like from top to bottom, what you can see here, we have the ability to post the subgraph if we want. We have a bar, progress bar, just showing us how fast things are being indexed. Metrics are quite interesting over here. We're gonna be able to see from different timeframes the amount of entities that are being stored for the subgraph. API requests that are made to our endpoint. Basically, you see here, when I deployed the subgraph, I was given a public GraphQL link. So this is the endpoint, which I mentioned earlier. Now here I can query its information, right? So if we have a good idea of what are the actual, let's actually see entities. Over here, we can see that we have transfers and we have also approvals. So this is info that we can be querying from the endpoint itself. And whenever I do an API request, you will see that the bar will just go up and it will show up into the metric explorer, basically. So that'll be one thing. Another thing that might be worth mentioning is in some cases, you may not want to have your data publicly exposed. And there are several reasons for it. Maybe you're building it kind of in private. Maybe you just don't want anyone finding your endpoint to be able to access that information. In that case, you can very easily create a private GraphQL link. So in this case here, you're not able to query the endpoint unless you have the appropriate authorization header. So it's just a way for you to keep things private in case you want to build in private, basically. So that's one thing. We also provide you with metrics around, the performance of your subgraph. In some cases, what happens is that you may deploy a subgraph and it then that ends up being just like inefficient on the mapping side. Of course, like the ones that we deploy for you, the ones that are going to be instant subgraph, they are optimized to be really fast, right? But in case you go ahead and you deploy your own subgraph, you're going to have some metrics here around, the average time for each handler, as well as if you have any if calls, how long they basically take on average as well. And this allows you to, pretty much optimize the speed of indexing. So that's going to be one thing as well to mention. You got the number of entities being stored, which is actually already quite a few. So I reckon we are almost approaching the 100. And as well, you're going to have some logs here. Logs are quite useful in case you find any issues, but also if you find issues you can solve yourself, you can always reach out to us, provide us with the log, and then we can look into it further. There are some of the cool features in terms of subgraphs. For some of you who are familiar with it, you will realize that subgraphs also have their own, let's say, API endpoint, as you can see here. In some cases, this is not convenient as you go and publish new version of subgraphs. Let me give you an example, right? Let's say you're working on version 1 of a subgraph, you keep on iterating on them, and then for whatever reason you create version 3, version 4, ends up being that version 4 is the one you want to go with for production. every time that you make changes to these versions, then you're going to have to also update your client code to be able to read from that API endpoint, right? So as you can see here, we have a fixed API endpoint working over here. The thing is, in reality, we can also like make this endpoint to be fixed, right? And so to do that, we will be creating these tags basically. So if I just click on tag, what these tags allow you to do, for example, I can create a prod tag over here. This prod tag is going to give me a fixed endpoint. So if I go ahead and deploy a second version of the same subgraph, we can actually have the same fixed endpoint over here, and we can change the underlying version of it so that your client applications don't need to be updated every time that you're making an iteration of your subgraph code. I think people find this quite useful, and it's also quite useful in terms of speeding up development time, because otherwise each subgraph change is going to basically mean a whole chain in your own infrastructure. So that's pretty much it. Maybe one last thing which is worth mentioning, which also quite useful as well, it's webhooks, right? In some cases, you may want to get notified or notify external systems whenever there is a change in your subgraph in terms of the number of entities being stored. You can create webhooks that go into your HTTP endpoint, and then you can just basically get notified whenever there is a change in any entity. In this case, we only have 2 entities, so that will be 2 webhooks that we can create. And then these webhooks will get released whenever there is an update, an addition, or a deletion of the corresponding entity. That's pretty much it in terms of subgraphs. As I mentioned before, subgraphs are actually quite useful. As you can see here, they provide you with that API endpoint. You can also make it private as well. And you also have the ability to get some insights into how to speed it up in case things are not working well. And that's pretty much it. Of course, you can always delete the subgraph to, pretty much avoid incurring costs. But yeah, for the rest, I would say it's a pretty easy experience, especially considering that we haven't really had to basically code anything. We just got everything done by Goldsky itself using this instant subgraph configuration. Okay, cool. So that'll be the first thing that I want to talk about. That would be subgraphs, which I believe anyone or most people are quite familiar with these days. The second thing that I want to talk about is more about what's the next step, right, within indexing. Well, we talked about at the beginning how originally people were making RPC calls directly to the blockchain to read, inefficient by itself, right? Like it's going to take a long time to even list 20 NFTs. Then we transition into indexers with subgraphs as the best next technology. And it's actually great technology because it can cater for a number of great use cases, especially those where you don't want to you don't want to mess with the infrastructure itself, right? You just want to have the data. I want to have an API endpoint to query from. Now, if you go beyond the standard use cases and you get into actual scale use cases, right? And you need faster speed because maybe you have a low latency application, some sort of a DeFi app or maybe a gaming app. Or for example, if the chain you're tracking is actually very fast in terms of block production, then in those cases, subgraphs will start falling apart because in some ways, subgraphs are quite efficient, but it can be quite inefficient by how they work. They basically will index information in a sequential way, which works well for some use cases. But as I said before, for cases where you have a bunch of data and the chain is fast enough, your subgraph is never going to be able to keep up to edge. Another drawback of subgraphs itself is the fact that you can only query the data via the GraphQL endpoint. And so for some cases where you may want to power, for example, applications that involve off-chain or cross-chain merges, or maybe you want to do really fast searches, like fuzzy search, for example, or you want to do aggregations, or you want to build your own API on top of it, that GraphQL endpoint is actually not that convenient to work with. And those are cases that we see more and more as companies scale and deal with more complex use cases. So to that, we basically created a paradigm shift in terms of, data indexes. And this is why we created Mirror. So with Mirror, we look at indexing in a different way. What we do here now is we will basically index raw data of the chain that you're interested in. And from there, you can create ETL pipelines that will allow you to stream in real time all that information into the database of your choice. So in your case, let's say if you have a use case which is around analytics, then you can get that information over a ClickHouse instance. If you are looking for more transactional type of use cases, then you can get that data into MySQL or Postgres. Anything can work out as well as webhooks, right? Like webhooks are still there. So if you want to keep that webhook endpoint open, you can also do it that so. I think it's very interesting as well because, on the source sides, right? Like the pipelines will consist of three components, which I'm going to be talking about. But one interesting use case here is that if you are, for example, a multi-chain dApp, or you need to have full visibility across an entire chain, like that's what everything is possible with pipelines, because you can basically use as the source of these pipelines. They can be subgraphs, they can be any chain that we have. They can even be off-chain stores like Postgres, and you can combine them both into the same data store, basically. So this is something that I wanted to show you now in a second. Let me just switch to, let's go back to the app again. Okay, cool. So the second part here, pipelines within the dashboard. The way I will go about creating a pipeline over here, very easy. I just go on, click new pipeline. So here, as I said before, pipelines consist of three main components. In reality, they can be only two. You need at least to have a data source and a sink. A data source, as I mentioned before, it can be a subgraph, or it can be the chain raw data sets that we create for the chain, basically. For the sink, we can go ahead and choose among a multitude of them, which I'm going to cover in a second. In between, it's optional, but in between, we can also define transforms. Just like you can think about this, if you have more experience with subgraphs, you can think about them to be similar to the mappings, right? In this case, these transforms can be defined like SQL transforms, or they can be defined like external handler transforms. The difference between the two of them is that this will be in SQL and they will run within the pipeline environment. The handler will basically be an endpoint that we call up and then that you host. You can think about it as being as like a Lambda, and then you will do the actual mapping or processing within your endpoint and then return the result back to the pipeline. All right, cool. So let me create a very simple pipeline here. In this case, all I'm going to do is create a pipeline that will track some info from the chain. So we have a bunch of chains here for Mirror. And in this case here, we will go for Etherlink. All right. What you see here is that as the source, you can choose raw blocks, logs, transactions, traces, as well as any other subgraph on the network that you have already deployed on the project. In this case, I can just like make it easy. And let's say I just want to have all the logs for transactions. At the same time, you can also get transfers and data sets as well. Now, raw logs again. Now, when you define the actual source of it, you can define the pipeline to start from the very beginning of the chain or the tip of the chain, which will be current. In this case, we can get all the data from the past. So this will be a proper backfill. At the same time, if you are interested in getting logs, in this case, from a specific contract address or some topics, you can add those topics easily or those filters easily here on the network. One thing that is pretty cool as well is that you can see the schema, so you can get an idea of the actual data that's going to arrive into your own database. So that will be this one here, and we can also get some sample data. So we get an idea of, okay, this is what I'm looking for, basically. Now, next, as I mentioned before, we can just go ahead and create a sink, and that'll be it. But just for the purpose of the demo, I'll show you a quick example. We can add a SQL example here. So this will be a SQL transformation. I can click on it and define the SQL transformation. So in this example, just to keep things easy, right? What I could do is I could essentially define, this source endpoint here. Sorry, this is the actual source of the data that I was looking into before. So what I can see here is I can define a transform, and all that is going to do is basically create a subset of the original data that I have. So let's say from the original sources, I'm just gonna get block number, block hash, and topics, for example. So this is a transform that simply shrinks the amount of data that comes from the original source. I can run it and I can get an idea of the result that I'm going to get. So you see the shape of the data. Let's actually see it. All right. All right, cool. So you see here, ID, block number, block hash, topics, and the corresponding types. So this will be the new schema that's going to arrive into my MDB. And here's some sample data. Cool. I just save this. And then last point here, I'm going to define a sink. And then the sink here is interesting because, as I mentioned before, we support multiple technologies for sinks. As you can see here, there's a bunch of different DBs that you can sync the data into. Something we recently released, which I think is actually very cool, is the ability to have, Goldsky hosting the DB for you. So we can provide you with a database, and that way you don't have to manage your own database. So this is for cases where, very similar to subgraph, right? Where you don't really have to stand up a DB to work with the data. This is the exact same here. Like instead of you having to, have your own DB, then we can host it for you. I can choose this option here. I already let's actually create a new one so we can see the full end-to-end flow. So let's actually see. I'm just going to create a new DB in this example. I'll try now over here. Postgres. All right, cool. So the way it works is that for Goldsky to be able to write data into a DB, whatever DB is, if it's our own hosted DB or if it's your own DB, ClickHouse, Postgres, whatever, there's going to be this concept of a secret. And so basically, a secret encapsulates the credentials that the pipeline uses to be able to write into that DB. And so what you see here, I just created this secret name. I'm just going to call it differently. So I'll just say this is hosted Etherlink demo. So this will be the name of my secret. Now I'm getting things ready here. So what we're doing in the background is we are provisioning the database. And now here I'm giving basically credentials to access these newly created DB. So I can get this psql command and I can just directly log into it. So I'll just show you a quick example of this. If I go here and I will exit this one here, clear. All right, cool. If I run this psql, I will just have access to this DB. If I just DT into it, you'll see that there is no tables created yet. It's a fresh DB. Now we're going to deploy the pipeline and we'll see the pipeline creating the table for us. So, all right, cool. Now what I'm going to be doing here, this is being created, pretty good. And I'm going to choose this hosted Etherlink demo. Cool. Now I need to set a name for the table. The created table, maybe something like, let's say raw logs. And that's pretty much it. We've created the pipeline already, which consisted of a source, an optional transform, and then a sink. In this case, it's going to be a Goldsky hosted database, Postgres database. Right, I'll put a name for this. I'll say Etherlink demo. That's going to be the name of my pipeline. And then last but not least, I can deploy the pipeline. When you deploy a pipeline, you can define the resource size. This is basically the amount of compute that you want these pipelines to have. So they can be from small all the way to XXL. You can think about then small being 1 worker, XXL being 40 workers. And so it differs, right? It's different on your use case. If you have a huge backfill to do, then you will want to increase the resource size of it. If you have a big pipeline to do, for example, a pipeline that uses many data sources, uses cross-chain combinations, you will also want to go with XXL. in many more cases, if you have a data of you're looking at edge data, pipelines are going to be able to keep up with edge very, very easily. Basically, it's going to be able to process around 2,000 records per second. All right, cool. So I'll just click on small because, yeah, this is all we need at the moment. And and now the pipeline is going to get deployed, basically. Cool. So while now we've been redirected to the pipeline details page. And so over here, we're going to start seeing the pipeline writing records into my newly created database. While that happens, I'll take you through this page, basically. You're going to see the record receipts by the pipeline and the records being written on your sync over here. So these metrics will change as soon as the pipeline is ready. You can see here a nice description of the pipeline. And then this is kind of important, actually, because pipelines are officially defined using YAML files. Some people prefer to work with the UI, other people prefer to work with the YAML files. And this is actually being done on the CLI, which is something I should have maybe mentioned at the beginning. Like everything that you do at Goldsky on the UI, you can very easily replicate on the CLI. We have let me just walk you here. So over here, I can just basically do Goldsky, and I have my own CLI command here. And as you can see, I can create pipelines with mirror on deploy subgraphs, which is basically the exact same kind of experience that you get on the UI. When you work with the CLI, you can also work with the YAML files directly. And this is very powerful in cases where you may want to, for example, automate the development of pipelines or the process of deploying them via CI/CD, etc. It allows for more complex scenarios, let's say. All right, cool. While I was talking, this, the pipeline was already writing records. If I scroll down, I can see the logs here. So we see that the pipeline created a new table, which is called raw logs. Actually, raw logs. I forgot a G in there. And then started writing records into it. So if I go back into here, and then I run DT again, I can see we have this here. So what I can do now here is, let me just put this in a better view. I can basically do select all from raw logs. I will just limit it to 10. Cool. So now we see the data being transferred stream in real time into my own DB, which is actually being hosted by Goldsky. So yeah, that's a full end-to-end example of how we can basically take data from Etherlink and deploy that data and stream it into our own database or a Goldsky hosted DB, and whatever works well for you and for your use case. Now, from this point onwards, you own the data, right? So now you can do whatever you like with it. You can create APIs on top of it. You can collocate it with other sources of information. It's really up to you to decide what you'd like to do. Now, this is a much, much more scalable and faster approach than pipelines because, as I described earlier, pipeline workers can be scaled in parallel. So you can actually get horizontal scaling going on as the chain activity goes up, essentially. All right, cool. So that finishes my presentation for today over here. I will make sure to share this, slide with you guys. There is also a feedback link in it in case there is something you'd like to see on a future workshop or something that we miss on this one, which might be important. But yeah, I will also add here some resources that you can follow up in case you also want to give it a try to everything we've explored today. But yeah, really, really really happy to be presenting today and having the opportunity. And hope you guys learned something new and you enjoyed the session.
Thank you so much, Javi.
Thank you.
So all the links will be in the description down below. And yeah, if you have any questions, the comment section is yours. Definitely, I would love to see a little bit more workshops and maybe we can come up with some sort of cool use cases for subgraphs or the mirror. Actually, when you were presenting, I was thinking about quite few of them, and maybe next time we can do a very simple functionality together. But I think it's all great for now. Please play around. Please use Goldsky and just both CLI and UI way. I think it's very playful and very, very intuitive. But if you have any problems, if you're stuck at some point, we're here to help you.
For sure. Yeah. Yeah, that's for sure.
Thank you, Javi, and
you.
see you on the next workshop, hopefully very soon.
Yeah, thank you. Have a good one.
Thank you. Bye.
Bye.